PowerCad's been in the Australian building industry for 20 years. This was our initial release back in the early 90s. And we now have a significant product range which is mainly used throughout Asia Pacific and throughout other places around the world that have 50 hertz electrical systems. I'm going to go through just briefly what we do, our different packages, why we got involved with the BIM MEP Oz initiative, and how that helps our electrical workflow. I see a raise of hands. How many electrical engineers are in the audience? A couple. This will be quick then. All right, so we have a range of software. PowerCad-5 range we sell to electricians up to consultants. It's a standalone software that does some high-end electrical calculations. And in the last 2 years, we've released a couple of Revit apps, P&L, a free app, and PowerCad-M, a licensed app that interfaces with PowerCad-5. So PowerCad-5, we have a lot of manufacturing data in there that helps do the electrical calculations. And we do things like voltage drop, cable sizing, conduit sizing, fault loop impedance, a lot of these electrical calculations that the industry needs. Now PowerCad-M, we've developed in combination with our customers. I'll go through the workflow in a sec, but it was born out of a request to interface with Revit and to use a lot of the information that was already stored in Revit. We've been working on that for 2 years. The first release was just over a year ago, and we do probably 3 releases a year of updates to that. So these are the workflow that we propose to our customers. The historical workflow we've had is a smart block in AutoCAD, which stores a lot of the load data. And then we push that into PowerCad-5, do all our calculations, the cable sizing, equipment selection, and so forth, and then automatically draw a single line diagram in AutoCAD. And with a lot of our customers moving away from AutoCAD, we've started developing the Revit interface that I talked about. And our workflow at the moment there is we'll take as much information as we can get out of Revit, push it into PowerCad-5 to form the basis of the electrical calculations, and then either push that into AutoCAD or push it through AutoCAD and back into a Revit drawing. So the useful information that we get out of Revit at the moment is the switchboards, their identification, where they sit within the building, the levels they sit within the building, transformer, the power grid information, how everything's connected up, cable length between the boards, and all the final sub-circuit loads. And that's the basis of the information that's currently in Revit that's useful to us. What we need to get that successfully out of Revit is all the electrical connectors modelled, the correct electrical distribution settings so you connect everything up, all the electrical components connected, the correct electrical loads into the families, and the connect cable routing is also nice to have. So as we went through the development of PowerCad-M, we talked to a lot of our customers. We looked at a hell of a lot of their models and what they were and weren't doing in the electrical space. We found a very low take-up of electrical in Australia in general. Our apps are also sold into North America and globally, and we find that in North America, every model I've got back is fully connected from the electrical side, whereas I don't think I've seen one model out of Australia where any of the electrical stuff's connected. There's no trust in Australia in the electrical calculations being performed by Revit. Most of the families lack the right electrical data. And the standard Revit families don't cover everything we need to do the electrical calculations. And I guess the end shot of all that was the effort in fixing all those things outweighed the reward that our customers were getting out of connecting everything up properly. This is a good example of one of the models that I'd looked at. And if you've never played in Revit electrical, it's a bit hard to understand, but this is all your different distribution systems. And this particular model had 3 or 4 distribution systems all named the same. So in Revit, they had a whole lot of different electrical systems named the same thing. And to undo that, unconnected the whole model. And this one had about 3,000 switchboards in it. So there was no going back from this particular setup in this model. So we've built this interface, PowerCad-M, and that helps with connecting things up in Revit. This is a drag and drop interface. So as you drag and drop the electrical loads or the switchboards around, all the connections are done in the background in the model live. So you can actually put this on a separate screen, have your 3D model up in Revit, and be dragging and dropping all the switchboards around, and it updates the model live. So that started to talk to making it a bit easier for people to connect up the electrical side. The next issue we had was not enough electrical information in the families, and what we thought we would do we'll develop a whole lot of PowerCAD parameters, and then we'll push that out to the industry and say, right, if you want to use our software, you need to load all these parameters into your families, and that got met with quite a few comments. People didn't need more parameters, and particularly didn't want us developing parameters for them to use. And that's when we got involved with the BIM MEP guys, and this is a really good forum to get, for us, ourselves, manufacturers, consultants, and all in the same room talking about what we need in models to make this workflow successful. And the output of those workshops is a bunch of specifications which we've talked about earlier, and they're on the BIM MEPO's website, and they lay a really good groundwork to creating families that we can use throughout our software and from consultant to through the workflow to get the calculations right. So I'll flip through this. So the 2 important things in the specification for us as a software company, and with our mission to get people to connect up everything in Revit, is having the right connector settings. So we've spent a lot of time making sure that we list out what we need in the connector settings in each one of these specifications to make sure that when you drag and drop a component, it will connect up in the system. Has anybody tried to connect up electrical system in Revit? There's a real issue with not having enough feedback on why stuff won't connect. So the other thing we've done is we've spent a lot of time trying to preempt errors, and through our interface we throw up those errors around why, if you don't have the right distribution system, your connector settings are not right, your poles don't match between what you're trying to connect up. But to get in front of that and to stop those errors occurring in the first place, we're laying out the connector settings through all these specifications on how they should be to get it all to work from the get-go. The next thing for us is parameter schedules, and what that does is that adds a lot of extra information into the families that we can then pull into PowerCad-5 to do the calculations, and we'll go through some examples of that. So this is how you currently see your electrical system in Revit. So a switchboard, this is your system browser. You can where you can go down through each of the circuits and find what you need. This is our interface laid over the top. So now it's a single line diagram interface where we can click on a switchboard in the single line diagram. It will find that switchboard in Revit, and we can drag and drop around, and as I said before, updates the Revit model. When we overlay the BIM MEPO's parameters over that, we can start doing a lot more in the single line diagram. So for instance, there's a energy meter location. The 3 examples here is energy meter location, the panel functional type, and the main switch isolator. We've added those 3 parameters into the panel board or switchboard. And now you can see if we select the location in the parameter, it will now draw the metering in the right spot. And we have I think we've got 3 different options there. We can put the metering down into the board or into the upstream board. Panel functional type. So this is a tee-off box here. You can't model a tee-off box in Revit. And one of the early projects I got, we went to move that from Revit to PowerCad-5, and we found that because it was full of tee-off boxes, it didn't actually move across into PowerCad-5 correctly. It tried to create a whole bunch of other switchboards. So with panel functional type, you can turn your switchboard into a tee-off box or a number of other things. You can do essential services and so forth. And then with the main switch isolator, you can change the type of isolator you have in your switchboard. And when we drag that across to PowerCad-5, we then drag all that information into our PowerCad-5 environment. So you don't have to do it all again. You don't have to remodel it, and it's all there ready to start the rest of your calculations. Is that going to work? So moving forward, we're quite keen to keep working with BIM MEP Oz and review and refine the rest of the electrical connectors, particularly through the mechanical side, to make sure if you put a bit of a mechanical equipment in to your Revit model, you connect it up to the switchboard, we're getting the right data out of the motor or the air handling unit or whatever you've got in there. We want to keep building on the list of parameters, not just for the stuff we can do now, but the stuff that we've got planned for the future. We're quite keen on getting a good electrical IFM library, which we talked briefly about this morning, and continue to build up specifications for the rest of electrical families that we haven't done so far. So I know I've rushed through it, but we're a bit over break time, so thank you.